Welcome to the lecture on the world economy and environment. Basically, in this lecture, to start this lecture, I actually want to show you a video from the Paris conference on the climate change. But before that, I should mention that before now, we have seen world economy. Up to this point, we have seen world economy mostly isolated from other aspects of the world. We now and then we have connected some social concepts of the world with the world economy, like the political system and law. However, we haven't gone beyond the human and social aspects of the world. I mean, of the world. In fact, actually, the systems we are mentioning in social sciences are not independent from them, from each other. They are not separate systems that can be put aside from each other. That are within each other and that are actually kind of growing inside of each other. So same units can be part of both environmental system and social system and economy, basically, when it is looked from different dimension. So in a way, I mean, economic system and environment are integrated to each other. Although to study them today, we will assume as if they can be separated each other and that can be treated as separate systems. Let's watch the Paris. I mean the video on the Paris conference, and you can see. I mean, it was a conference that was the reason for celebration was mainly this conference was a conference where there was an agreement on a major environmental problem, climate change, on almost all there was agreement on making solid commitments on every country to combat the climate change, which is the major environmental problem in current world. So it was, and you can see from the speeches, it was a conference where many people were excited. Although those commitments, according to some people, were not enough. At least there was something was beginning, basically, according to them. Well, today we will not go to much detail to the environmental aspects of this. I mean, how environmental work and what kind of a problem. How climate can change and what are the dynamics of climate change. We won't see those details, but we will see from the economics perspective, and we will see pretty much with ifs when we take certain aspects of the environment as assumptions, how in that case will affect economic system, the environment, and basically what can be done from the economic perspective to solve that problem. So, as I have said before, we have separated the environment and the economy, and when we have done that, basically, environment in its most basic form serves economy in two different ways. It is the place where energies and resources are taken to the economic system to be used, and it is the place where the wastes are sent, basically, to be absorbed. And when we take environment in this sense, we have we might have two different type of actually, let me say, three different types of problem, basically. Actually, from very basic sense, we have two different problems, but both of them might have also lead to this problem. Although economy can lead to the third problem also in different ways. The first problem is resource side problem. Basically, when we are taking from environment the resources below a certain limit, environment can reproduce those resources. If you take just a water from a river, the river will produce the lost water again, or a lake from a lake will reproduce this water again. But when we use the resources above a certain limit, in that case, those resources starts to deplete, and that's our first problem, the resource side problem. The second problem is waste side problem. The waste side problem is basically when we put a lot of waste to the environment. Well, first, when we put waste into environment absorbs that waste. But when the amount of waste that is put to the environment exceeds a certain limit, now the waste will start to transform. I mean, it's not anymore possible to absorb the waste, and waste that is put to the environment starts to be change the environment. So both resource side environment case and waste side case basically change the environment. From the economic perspective, that change can be important because the energy and resources, even as simple ones as air we breathe, which is also a resource in very basic sense, might change, and it might change it might also very well change in a way. Those resources might be reduced or become inferior. So we want to prevent that change, and in order to prevent that change, we need to put the resource use and waste depletion below a certain level. Well, the third type of transformation might be we might, as humans, transform our environment for our use, and that itself might create change in the environment, and it itself might create basically reduce in the energy and resources we got from the environment. But this broader type of potential transformation, I'm neglecting. I'm not I won't talk on it for now. I'm for now looking to resource side and waste side problem basically. But this is another problem. I mean, the way we change environment to make it more suitable for our use, and as a result, the resources in the environment might also reduce the resources that are taken from the environment. This is from Trabzon, Uzungöl, by the way, I believe. So both photographs are from the same lake at different times. So how do we put limits? First, can we leave the problem to the market when we leave the problem to the resource side problem? If as the water of the lake gets smaller and smaller, and the amount of water we can get from the lake gets inferior, or the water we get from the lake gets inferior, or it becomes more difficult to get water from the lake, or the amount we can get of water we can get from the lake gets less. In that case, basically, price mechanism of the market can work and basically solve the resource side problem, because the price of water might be more expensive and people might look for alternative resources. But the depletion might come. Well, the depletion can start actually a lot before actually the price mechanism, its effects on price mechanism can be felt. And if that's the case, basically, when price mechanism starts to work and starts to increase the price of water, the lake might already be depleted. So we have an imperfect mechanism, but there are conditions for this mechanism to work efficiently, basically. For the waste side problem, unfortunately, there is no such mechanism, because when we deplete the waste, that depletion doesn't necessarily cost anything unless there are some rules on waste depletion. We need to do some spending to ensure the waste doesn't do any harm at this immediate at our immediate environment, and the waste degrade environment. It make our environment worse. I mean, it might potentially may damage our environment, but damage is at least shared by the local everyone at the local ground. In extreme case, it can be shared by whole humanity of the world, which means actually waste side problem is classical. Waste side problem is a classical problem where we can make the cost of our actions be shared by everyone, and our individual level, the individual cost of share of cost from our individual action is very small. But when everyone does the same action, then the cost will become very large for everyone. So basically, to define the problem, one thing we can do is we can basically say, well, when there are limits, in some cases, for example, when we use sun at this stage of our civilization, there might be no limit. But when there are limits of waste disposal and the resource extraction, then yes, in that case, we have a waste side or resource side problem. And for all resources and for all waste we dump and extract, for some of them we might have this problem. And whether or not we have this problem also depends on the biology and chemistry of our world. Here, actually, this is the border we come. After this point, whether we have this problem pretty much depends on the other basic natural sciences. And problem of entropy is actually a special problem when we are coming to the energy. And this is basically depend on created by a law of chemistry. But here I should mention that law because it shows actually the basic energy problem. According to law of entropy, the useful energy of any closed system continuously decreases. So whenever chemical energy is transformed by the sun to light, energy of light basically, or energy of heat, or any energy is transformed into different energy forms, the useful energy basically available in the system decreases. It's like, for example, you might have different waters in different cups that have different heights, but you might think when I pour this water to the other cup, basically my useful energy will decrease because on average the height of water on every cup becomes more similar whenever I use the energy, available energy of waters by pouring water from a high at a higher length at a cup to a cup with a lower length, basically. I mean, by directly opening channels between the cups, basically. Of course, if I can lift the water and drop, in that case, that means I'm using energy to use the water energy. But if I just open certain doors between the cups and pour that way, in that case, water can only drop up to the point when the heights become equal. And the more I use energy of water, the more the heights of water becomes equal on average, and available energy in the cups gets smaller. I will talk more on this in the next parts.